Good morning, everyone. Today is Monday, March 6th. So, if you haven't come to see me last week, please come to see me this week. Okay, I really hope to meet you quickly and let's improve. Okay? All right. And also, if you haven't made an appointment with a tutor from the OSS, this is our course website. And then here you see the Math Weekly checklist. Okay, I give you a checklist, but if you lose it, feel free to print some out or come to my office to grab one. Okay, and let me see. All right. Yes. So my office hours, Monday, Wednesday, Friday from 1 to 1:50, 3:15 to 4:15. But usually if I don't have meeting, I will stay in my office until 5. Okay. And Tuesday, Thursday, 11 to 12 p.m. But usually Tuesday and Thursday, I only have a class from 2 to 3:15. Then I should be in my office from 10 to 5, except 2 to 3:15. Okay? So if you walk by my office, I'm there. Feel free to come in and meet me. Okay, everybody? So, or by appointment. My office is in Snyder 159. And then here, how to schedule a tutoring appointment using Starfish. So it's like print screen, step by step. Go to Blackboard, click Starfish, pick your course, and then find a tutor and pick a time to meet a tutor. Okay? So do all you can to improve. So meet me, meet the tutor, review your notes, do your homework, do the quiz, do the practice exams. So if you haven't submitted the practice exam, you can still submit it and get 10 points. Okay, everybody? So use pencil to finish first. And then once you click the solution, use red pen to make corrections and estimate your total score. For the exam correction, I have already posted the exam 1 solution. Okay, so click the solution and use red pen to make corrections on your exams. After you finish, scan the entire exam. So you take pictures of your entire exam, including the front page, your score page. Okay, everybody? That is exam correction. And then exam wrapper. So this is the blackboard. Exam wrapper and corrections you submitted in the self-assessment. Okay, so practice exam 1 submitted here, exam correction and wrapper. So exam wrapper is like a survey, asks you how did you study for the exam and what mistake did you make? What will you do differently? And how can I help you? Okay. All right, so I hope to meet you weekly and let's try our best to improve. And today, let me see. This week we have homework 6. So homework 6 is about 2.4, 2.5, and 2.6. So some of you missed classes last week. Please print out the handout and watch the recording and take notes. If you have questions, come to see me. Okay, everybody? So the quiz 3 will base on homework 5 and 6. So that means session 2.2 to 2.6, but mainly focus on 2.5. Okay, so 2.5 transformations. You need more exercise. Okay, so that's why in the 2.5, besides our regular notes, I give you 2.5 practice problem and answer. Okay, so you do that one because your quiz is going to be similar to that. Okay, everybody? Let's review again. What are the basic shape of functions? Line. This one, right? Parabola. X squared. X cubed. Square roots. Cube roots. Absolute value. Okay, right. So review that. It's very, very important. If you forget about the shape. Don't forget you can plug points. Plug in x is 0, x is 1, x is 2, x is minus 1, x is minus 2. Look at your y value. Plug those points on the xy plane and connect them smoothly. Okay, everybody? Yes. All right. So today, let's start chapter 3. Bless you. 3.1 Quadratic functions and models. A quadratic function is a function that can be written in the form of f of x equals ax squared plus bx plus c, where a, b, c are real numbers with a is not equal to 0. Well, that is because if a is 0, this term is 0. You just get a linear function, right? So quadratic, you have to have x squared. So the a cannot be 0. Okay? This is a quadratic function. The graph of a quadratic function is a special type of U-shape, like parabola. Okay? So we call parabola. Just one L. Okay, parabola. And it looks like that. Oops. Like a U shape. All parabola are symmetric with respect to a line. That is called the axis of symmetry. So you see, this parabola is symmetric with respect to a line, right? And then this, on the left side is like mirror image of the right side. So it's symmetric with respect to this one. It's called the axis of symmetry. The point where the axis intersect the parabola. So this is the axis. This is the parabola. And then this point, you see, they intersect. This point is called the vertex of the parabola. Okay, so vertex is this point. And axis of symmetry is this line, vertical line. Okay. And then those are the terminologies. How does the value a affect the parabola? Okay, so sometimes we call this is the general form of the parabola. There are other forms, okay? It's like for line, we have slope intercept form and we have point slope form. For quadratic functions, we have general form and we have standard form or called vertex form. Okay, we'll talk about that later. So how does the value a affect the parabola? A is the coefficient of x squared. If a is positive, then our parabola opens up. Okay? And if a is negative, then our parabola opens down. Okay. So y equals ax squared plus bx plus c. A is also called the leading coefficient. Okay? And b is the coefficient of x. C is the constant term. Okay, so we look at the leading coefficient. Hi, we have a handout today. Yeah, if A is positive, then the parabola opens up. If A is negative, the parabola opens down. Okay? And when A is greater than 1, the graph of y equals a times f of x is the vertical stretch of the graph y equals f of x. Do you remember in 2.5 we talked about transformations? Right, everybody? What was the order of transformation? We have what? First one, shift left or right. So shift left or right. Which one is positive? Left is positive, right is negative. You know what I'm saying? I'm saying xy. And we change to x plus or minus c, y. the y remain the same, and we change the x. Okay, everybody? That is step 1. Step 2. What's step 2? Up or down is the last one, the 4th one. Reflect over the y-axis. Reflect over the y-axis. And so you put a minus sign in front of x or in front of y? Y-axis. You put a minus sign in front of x or in front of y? From here to here. Do you see it's the same method? Yes, in front of x. Because your x is negative, your y remains the same. Do you have the picture in your mind? Everybody? You have the picture in your mind. So you have this point. It reflects over the y-axis. Do you see it's the same y, but your x now become minus x? Yeah, have the picture in your mind. So negative x and y remain the same. How about the third one? Yeah, reflect over the x-axis. And then you put your minus sign in front of what? Y, exactly. Because if you're at this point and you flip it down there, your x coordinate is the same, your y coordinate, you flip it down, so it becomes negative. Right, everybody? So if you really forget, draw a picture. Reflect about the x-axis. So go down, okay? Your x-axis, x coordinate the same, y coordinate have a negative sign. And also we have vertical stretch by a factor of c. And are you changing the x or changing the y? The y, right? You multiply by y a number. Same thing here, okay? A, if you multiply the function by a, and a is greater than 1, you have a stretch, vertical stretch. If your a is between 0 and 1, you actually have the horizontal compress or shake, right, everybody? And last one, what's that? Yeah, shift up or down. Which one is positive? The up is positive. So your xy, we're changing the x or changing the y? The y plus or minus c. Okay, so this is the order of transformations. We must follow this order. Because if you don't follow this order, your transformation will change. Instead of shift to the left, it may shift to the right if you switch the order. Okay, so please keep that in mind. Review it every day because we use it a lot. Okay, example 1. Sketch the graph of each quadratic function. Compare with y equals x squared. Okay, so y equal to x squared, this is the parent function. Okay, so here y equals x squared. What's the shape? Move your hands. What's the shape of? Yeah, like that, like a U shape, right? And what are the key points? If you plug in 0, what do you get? 0 squared. 0. If you plug in 1, what's 1 squared? 1. If you plug in 2, what's 2 squared? Bless you. 4. Right, everybody? And when you plug in minus 1, you get what? Minus 1 squared is 1. When you plug in minus 2 squared is 4. And we connect them smoothly. Okay? So you not only know the shape, you also need to know the key points. Do you remember, everybody? I told you each graph has key points. Okay, they are integer points. So now, what happened? Well, this This is x squared. This is 1/3 x squared. So we're like multiplying the y by 1/3. Yes, everybody? Then because 1/3 is between 0 and 1, so we get vertical compress, right? So we get vertical compress by a factor of 3. Okay, when you say compress, you compress by a factor of 3. But when you say stretch, you stretch by a factor of 1/3. Yes, everybody? So, what happened? That means the x remain the same, but the y we multiply by 1/3. Okay? So look at your points. 0, 0. X remain the same, still 0. But the y is 0. 0 times 1/3 is still 0. Right, everybody? And then how about 1, 1? 1, 1, 1 and 1/3. So 1 and 1/3 right here. Okay, so 1 and 1/3. How about this point 2, 4? You get the x coordinate what? Will your x coordinate change? 2 and 4/3. Yes. So 4/3 like here. So 2 and 4/3. And then we connect them. And how about -1? You get what? -1 and 1/3. -2? You get also 4/3. And connect them. Do you see this graph? It's like this graph, you compress it. Right, everybody? So x coordinate, think like here. X coordinate remain the same. The y coordinate multiplied by c. Okay, everybody? All right. Oh, how about this one? Part B. Do you see it's -2 is negative? That means we have what? Which one? Reflection over the x or the y. The y is a negative in front of the x or is negative in front of the whole thing? The whole thing. Then we're changing the y. So this is reflection over the x-axis. Is that clear, everybody? Because the minus sign is in front of the whole thing. It's not just in front of x. Okay, what do I mean by in front of x? It looks like in front of the x. In front of the x, I say really just right in front of the x. Okay, inside the square. Do you realize, oh, because the square, this is the same as x squared. Because -1 squared is 1, right? And which is true, because for x squared, when you flip it over the reflection about the y-axis, you get the same graph, right? And we have named for such functions. They are even functions. Even function is symmetric with respect to the y-axis. Do you remember that? Yes? Okay. So that's what I hope you review your notes. Okay, because we learned those in class. You review it, you can remember it. If you don't remember, then review your notes again. Okay, so then this one, yeah, because of the negative, we have reflection. So this is reflection over the x-axis. And what happened with the 2? The 2 corresponds to what? Vertical stretch. Right, everybody? So we first reflection about over the x-axis, and we have a vertical stretch. Okay, now let's do it. So you start with y equals x squared. With fraction over the x-axis. How about you guys take turns to answer my question? Clinton, with fraction over the x-axis. This point, what's the new point? What's the refraction?
-2, -4.
Yeah, very good. So -2 and -4 right here. Okay, yeah. How about this point when you reflect? What's the new point? -1 and -1 as well. Yes, right here. Hey, how about the 0? It's gonna stay. Exactly. Good. I don't want to erase it. Okay, stay. It came out. Yeah, 1, -1. And Zach. Yes, 2, -4. Okay, we connect them smoothly. Oops. Let me make it better. Okay, so this is y equals -x squared. And this is reflection over the x-axis. Okay, everybody? Now, how about vertical stretch? You look at the previous graph. Vertical stretch. What happened? Your x remains the same, but the y multiplied by 2, right? Justin, what happened to this point? What's the coordinate when you stretch? So this, will your x-axis change? No, so still -2. But your y coordinate, it was -4, but now it's okay, we're done with the reflection. We're doing stretch. Stretch, we multiply by 2. Stretch. So -8. Yes. So -2, and this is -4. -8 is right here. Okay, -8. And then Peter. Yes. -1, -2. Okay. David. How about the 0?
0.
Yeah, it remains the same, right? Okay, Dylan.
1, 2.
You mean?
1 -2.
Yeah, 1 -2. Okay, next one, Alexis. Huh? What happened to this point? What's the x coordinate? What's the x coordinate? 2. 2. How about the y coordinate? Yeah, that means -8. Yes, -8. So 2 and -8 right here. And then we connect them. Okay, do you see it like this picture? You stretch, right? You stretch by a factor of 2. Okay, so this is example 1. And now let's do harder examples. Okay, let me see. Okay, so I want to get a harder example. So let's not look at this. Let's put let's make a harder one. Let's combine them. So let's get -4 x plus 2 squared minus 3. Let's do this one. Okay, so we do less examples, but we do harder examples. Okay, so if you see something like this, what do? First step, always start with the parent function. So if you see quadratic function, the parent function is y equal to x squared. Okay, everybody? If you see x cubed, then yeah, what parent function? Y equals x cubed or square root of x, or cube root of x, or absolute value of x. Those are the parent function. Okay, so step 1, parent function, like that. And we already draw it. We have 5 key points. They are 0, 0, 1, 1, and 2, 4. Minus 1, 1, and minus 2, 4. So those are the 5 key points. So far, so good, everybody? This is the parent function. Start with the parent function. Then you go down the list. What's the first one? Shift left or right? Do we have shift left or right? Look at the x. Do you have x add something or subtract something? Yes. See, x plus 2. Plus is left or right? Left. Yes. Right. So now the formula. Okay, the formula. You start with this. Now you change to shift left. So x becomes x plus 2. So y equals x plus 2 squared. Is that okay, everybody? We shift left 2 units. Okay, everybody? So you start with the parent function. You shift left. So x change x to x plus 2. Okay. Now, weapon. Okay, shift all the points. We have 5 key points. Shift left 2 units. 10. If you shift left 2 units, what is the new point? A negative 2? You shift left. Negative 4 and positive 4. Right. Okay. Caleb, how about this point? We shift left 2 units. Positive 3? Yeah, negative 3, positive 1. Okay. Colin, how about the 0? You mean negative 2, 0? Yes. Right. Okay, which is here. Imani. Huh? Negative 1. So this point, you shift left 2 units. You get, what's the x coordinate? You get this point, right? So this is x is minus 1 and y is 1. Do you see this point? Yeah. Yeah, we shift left 2 units. And then you get x is minus 1, y is 1. Okay? If you cannot quite see it, feel free to stay here, closer to me. Yes. Okay. So this is the point. Kara! If you shift left 2 units, what happens? Yeah, 0, 4, right. Okay, now we connect them smoothly. So this is the first step, right? We shift left 2 units. Okay, what's next on the list? We flip over the y-axis. That means, do you have minus sign in front of x? Do you have minus sign in front of x? No, see? There's no minus sign in front of x. Okay, so the second one, we don't have the second one. The third one, what's the third one? We flip over the y-axis, which means, sorry, we flip over the x-axis, which means, do you have minus sign in front of the y? Yes. So y equals negative. Put a minus sign in front of the whole thing. This is we flat over the x-axis. Okay. We flat over the x-axis. Weapon. Oops. I don't want to erase it. So this point, we flat over the x-axis. It become, oh, Erica, you again. -4 and what? Yeah, very good. Okay, Quinton. How about the next point when you reflect over the x-axis? What do you get?
-3, -1.
Yeah, very good. Diana, how about the next point? It's stay. Yes. -2, 0. Stay. Hey. Yeah, good. Nikema. Yes. Okay. We connect them smoothly. Right, everybody? Okay, next one. What's next one? Vertical stretch. Yes. Reflect over the x-axis and vertical stretch. They're in the same step. Okay, so check both. Okay, so and we are multiplying by 4. Right, everybody? So your formula is -4 x plus 2 squared. Okay, this is vertical stretch. All right. Now, what happened? So let me move this up a little bit. Okay, so let's see. This point become what? What's the x coordinate? What's the new y coordinate? And the y coordinate is, what do you want to multiply by? You want to multiply by 4. -4 times 4.
Um,
-16.
Oh, -16.
Yes. So we got -4, but then -16, which is down there. Okay, so sometimes it's so small, then you don't need to really cut that point. Well, how about this point? Jackson, what's the new point of this one? -3 and -4, right? So -3 and -4 right here. Okay. Peter, how about this point? Yes, remain the same. -2, 0. David, how about this point? Yes, very good. -1. Eh? What happened to I erase it? Okay, -1 and -4. Okay. Dylan, how about this point?
0, -16.
Exactly, but -16 is too down there. Yeah, very below. So let's just draw it like that. Okay. So now the 5 key point becomes 3 key points because the other 2 point is too below. -16. We multiply the y coordinate by 4. If x remain the same, the y coordinate we multiply by 4. Do you see the point? Okay, for example, this point is -1 and -1. The new point, the x coordinate remain the same, still -1. But the y coordinate you multiply by 4, so -1 times 4 is -4. So the new point is -1 and -4. Mm-hmm. So I strongly recommend you to sit closer to me. And when I point to them, I will see better. Mm-hmm. All right. What's the last one? Shift up or down. And in this case, what do we do? Up or down? Down, yes. So that finally See, after this step, we get our desired function. Shift down 3 units. Okay, now look at those 3 key points. Let's see, what's next? Answers. What happened to this point? With shift down 3 units. What's the x coordinate? What's the y coordinate of the new point? Your x was yeah. The y? Sorry, -7. Yes. So we got -3 and -7. Oh, yes. The -16, when you subtract 3, is going to be -19. Yeah, because that's what, this is out of our graph. So you don't look at it. So that's why there's only 3 points on our graph. So just move those 3 points. Okay, okay. Caleb, this one becomes, yes, -2 and then -3. Chad, how about this point? -7, the x coordinate is? Still -1. So still -1, and then this is -7. So, and then we connect them smoothly. Okay, so this is our graph. Everybody clear the process? Start with the parent function, and then check the order. First one, shift left and right. Second, reflect over the y-axis. Third one, reflect over the x-axis and vertical stretch. The fourth one, shift up and down. And every step, you need to write down the formula, the transformation, and the graph. Is that clear, everybody? So your quiz is going to be like that. Alright, but your function could be x squared, it could be x cubed, it could be square root of x, it could be cube root of x, or x to the value of x. Okay, everybody? Alright, now standard form of the quadratic function. Okay, or sometimes we call it vertex form. Okay, so f of x equals a times x minus h squared plus k. Okay, so this is the standard form. Okay, we call our general form. So our general form was a x squared plus b x plus c, right? And then this is the standard form. If we're given the general form, how can you transform to the standard form? There are a lot of good information about the standard form. So if we draw the picture of the parabola, okay? So let's say this is a picture of the parabola. And then the graph of f is a parabola whose axis is the vertical line x equals to h. So with the standard form, this is the standard form. A times parentheses x minus h squared plus k. And h, x equal to h. Okay, this line x equals to h is the axis of symmetry. And then the vertex has coordinate h and k. That's why the standard form is so powerful. It tells us, oh, the vertex is h and k. Okay, everybody? And if A is positive, the parabola opens upward. If A is negative, the parabola opens downward. Okay? So our problem is, given a quadratic function in the general form, how can you express it in terms of the standard form? Okay, so it needs so-called completing the square. but we didn't learn completing a square. It's okay. Let's derive the formula, and then you just plug in the formula. Okay, so how do we derive the formula? Let's expand it. Do you remember a plus b squared is a squared plus 2ab plus b squared? Yeah, and then this one is minus, okay? So a minus b squared is a squared minus 2ab plus b squared. You know that, right? Everybody? Okay. So we want to expand this. So x minus h squared is what? X squared minus h squared 2xh. The middle term is minus 2 copy of x times h plus h squared. Is everybody okay with that? Mm-hmm. And plus k. All right, let's distribute. So when we distribute, we get a times x squared minus a times 2xh plus a h squared plus k. Yes, everybody? So this is what happens when we expand it. Let me rewrite it. Let me rewrite it as ax squared. And then I want to separate, so I want to put 2ah and then times x. I want to move the x at the back, okay, because I want to compare with the general form. Okay, so that's why I want to move the x later in the back. And then plus, I put a parenthesis here, ah squared plus k. Now we can compare. Look at the first term. Ax squared, ax squared. They are the same. Do you agree, everybody? Look at the x term. We have bx. Here we have minus 2ah x, right? So that tells us b equals negative. So b equals negative 2ah. Yes, everybody? Thank you. Did my alarm ring? Or it just did not ring? Or I turned it off? Okay. You heard it ring? You never? Okay. All right. So B is negative 2ah. And then C, you see, the C is ah squared plus k. Now solve for h. See, from here we got both sides divided by negative 2a. Then we have h is b over negative 2a. Right, everybody? And then here we can find the k. K is like c minus ah squared. Okay? So therefore, our formula for h, let me put it down here. H is b over negative 2a. That's h. And k, instead of using this formula, I'll give you another one. So k is f of h. Use this one is easier. Why? Because this point is on the parabola. Therefore, the k is f of h. Okay, everybody? So if a point is on the curve, then the y coordinate is f of the x coordinate. So use this formula. So what do you need to memorize? Memorize the general form, memorize the standard form, and memorize this formula. Okay? So before the exam, I will make a blank formula sheet for you, and then Please make sure you remember all the formulas on the formula sheets. Okay. So from now on, you don't need to derive the formula again. It's given. So, example 3, sketch the graph. Identify the vertex and the axis of graph. So, this is the general form, right? A is 2, right? B is 8. C is 7. Okay, so you identify A, B, C. Then plug in the formula. H, bless you, H is B over negative 2A. What's B? 8. Negative 2. What's A? 2. Oh. You see, once we have the formula, just plug in. What is 8 over negative 2 times 2? Negative 2, right? Because 8 divided by 4 is 2. So H is negative 2. Then what's K? F of H. H is negative 2. Okay, that means look at our formula for f of x. Whenever you see x, replace it with negative 2. Okay, everybody? So you have 2 times negative 2 squared plus 8 times x. Replace x by negative 2 plus 7. What's that? What's negative 2 squared? 4 times 2? 8. 8. Thank you. 8 times negative 2. Negative 16. And then plus 7. Oh. What's 8 minus 16? Negative 8 plus 7. Negative 1. Oh. You see, we get H and we get K. Then the standard form. Y equals A times X minus H squared plus K. Now you tell me what's the A? 2. What's the H? Oh, if you put negative 2, what is that? Positive 2. And K is negative 1. So we can rewrite it as 2x plus 2 squared minus 1. Yes, everybody? This is the standard form. And what is the axis? The axis. See? The axis is the line. X equals H. What's your H? Negative 2. So the axis is x equals negative 2. How about the vertex? Your x coordinate is negative 2. Your y coordinate is negative 1. Oh, see? When we draw the picture, vertex, negative 2. So this is negative 2. And then the y is negative 1. Do you see where at this point, right, everybody? Look at your A. A is positive or negative? Positive. Open up or down? Up. So you look at this vertex and then you open up. So it looks like something like this. So this is what your parabola looks like. So far so good, everybody? Yeah. So keep the formula in mind, then you don't need to do the complete square. So I know complete square method is hard. Okay. So yep, we will continue on Wednesday. Have a nice day.